We're here to talk about media playback the right way. So we're really going to kind of go through all of the different components and different system things that you need to actually integrate with if you really want a top-of-the-line media playback. So a little bit about me. I've been doing Android development for just about 5 years now. Started kind of on my own in my spare time. Got caught up in part of my master's degree, and then transitioned to doing it full-time, first at Funware and then at Facebook. I'm sorry I didn't fix everything I wanted to. And then there's a lot more I wanted to fix. But this last year, I've been working as a developer advocate at Google, so talking to the community and kind of bringing a lot of your feedback back to the engineering teams as well. I've been working on 2 major projects since then. We did an advanced Android class for Udacity, so kind of online learning, kind of going a little bit deeper into app architecture. And then as well, been just recently launched Android Development Patterns, a video series as well as pro tips around kind of all of the things that really are the best practices for Android development. And my focus has generally been on the Android framework and the Android support library, both of which play very nicely into this. Now, when we talk about media playback, there's actually like tons of levels and many things we could talk about here. And we're really going to talk about just one part, specifically audio playback. Now, it's important to note that if you're doing video playback, almost all of this still applies to you, right? The interactions with the system and that type of stuff still matter if you're doing video. But video has a little bit of a head start on us. The actual Cast Companion library is out. It's something our team actually supports and keeps up to date. But it encapsulates a lot of the best practices around video and integrating with things like Google Cast as well. So you kind of get that full multi-room experience. So let's start at the beginning. And the beginning should always be with the user, right? They're kind of the most important part in actually making our apps useful pieces of information. And when we think about that, we really want to think about what the user is expecting, right? When they're going into your app, what you don't want them is to be surprised in a negative way, right? But you want those positive surprises. They're like, oh, I didn't know the app could do that, right? Or like, oh, wow, it's actually doing everything I expect, and it's doing it great, right? And that's where we want our media apps to be. Not in meeting expectations, but really exceeding those expectations. And of course, for an audio app, you can't really do that without background playback, right? There's literally no audio app you'll find out there that forces you to keep the activity open the entire time you're playing audio. It just doesn't work very well on Android, especially when you consider phone calls and other interruptions like that. So we really need to get the basics down before we can exceed expectations. Now, when you think background playback, that should immediately ring bells like, oh, maybe a service makes a lot of sense, right? They're specifically designed for doing that kind of background work, not tied to any UI piece. Now, when it comes to media playback in a service, what kind of things are we actually doing in that service, right? So naturally, every service is created at some point, right? That is what kind of kicks off the process. That's our one-time feedback or one-time initialization kind of step. And then for most media apps, you kind of have 2, I would say, top-level states. You have playing, which I'll use as shorthand for audio is actually coming out of the device. And then you have paused, which is kind of all of those other states, whether they're buffering or actually paused, where audio is not being played, but is in a state where the user may want to transition back to playing. Similarly, stopped is kind of the final state, right? When the user says, I'm done with your app, I've moved on, maybe I've opened up another media app, etc. And then, of course, services hopefully eventually get destroyed. And this is where we'll reclaim our final memory and get back to kind of a steady state of our app is not running. So it wouldn't be much of an audio app if we didn't actually play audio. On Android, we have a media player, which does exactly that. It's really good at playing audio tracks, but it's maybe not the most customizable thing of all time. We do have EXO Player, which is another player that's supported on higher API levels that you can use if you need more control over here. But for the whole rest of this talk, everything I talk about will be player agnostic. So whether you're doing something that specifically requires media player or EXO Player, should all fit in the framework of everything else we're going to talk about. So how do our events that we just talked about map to, say, media player? Right? So it's actually really straightforward, right? We're going to create a new media player, and then when we're playing, we'll prepare and then play the track, pause, stop, and then when we're finally destroyed, we'll release all of our service, right? This super straightforward creating and getting everything done. And we're done, all right? Lots of time back. We're playing audio, right? But the problem is that just playing audio in the background is probably a detriment to users rather than a positive, right? We've given them no controls over it, and other apps are now trying to interact with them, and really we're in kind of a net negative kind of perspective. But what we actually want to do is go a lot farther. And that actually means that we need to do a few more things to actually get us to play nicely with the rest of the system, be a good citizen on Android, and really be the best app we can be. So the first thing here is going to be audio focus. Now, audio focus is kind of this key in Android of being that good citizen, right? It's that concept that your app is going to play audio, right? And that is your consideration of being the audio focus, right? But that doesn't mean that you can ignore every other app on the system, right? Every notification beep that comes in, right? Other players starting. Maps navigation is a really good example of this, right? We really want to be considerate of those other apps when you're doing audio playback. Now, this is slightly distinct from actually playing audio, right? We'll actually still want to use audio focus when we're paused or in that kind of intermediate state, because if another player were to start playing while we're buffering, for example, we still don't want to talk over that other app when we're actually ready to play. So some code actually registering our audio focus. And we can see here, we'll use Audio Manager for this. It's kind of the core for doing this core audio kind of work. And then we'll call request audio focus. In this case, we'll pass in a special on-stream listener, which is where we'll get these callbacks back. And we'll talk about that momentarily. And then we'll want to say we're streaming, say, music or media. And then we're going to say we're going to gain audio focus. Now, in almost all cases, you'll get granted back. The system will say, oh, great, you are requesting audio focus. You are a nice app. I like you. And you get audio focus. Now, there are some examples where you won't get audio focus. For example, if the user is currently in a phone call, you won't get audio focus in that sense because they're actively talking in a call. And you'll want to wait until the actual phone call is done and then do the call from there. Or have the user repress the play button when they're done with their phone call. So what does that focus change actually give us? Well, it's really kind of that key between our app and all of the other apps on the system, right, where we get all that information. So, for example, you may get an audio focus loss symbol. Now, this is kind of that permanent loss of focus. Right? At this point, they've said, well, the user has moved on. Another app has said, I want to gain focus forever. And it's not coming back. It's not coming back. So in this case, you probably just want to stop playback. You say, all right, I will gracefully exit stage and allow the other app, which has requested focus, to continue on. Now, one thing you might consider here is if the user accidentally hit the play button in another app, instead of immediately stopping. You may pause, wait 30 seconds, and then stop, right? That's certainly an active pattern if you want to prevent some of those false negatives. Now, another one that they can use if someone is using gain transient, in this case, the other app is asking for you to stop temporarily, right? So in this case, we probably just want to pause the playback and wait for them to finish their 15 seconds or whatever. So you may take this as an example of someone saying something out loud, or say you're on a running app and the running app is saying, like your splits and pace, and maybe they don't want to talk over your other app. They just want you to pause for a second, and then you'll come back. Now, the last transient one is actually called can duck. And we talked about ducking earlier. This is a different ducking. This is actual can ducking, and that really just means lowering the volume temporarily. So in this case, this is what, say, notifications use, right? When you get a notification in, instead of the music completely stopping, it'll just lower in volume. You hear the chime, and then it'll come back up. And it comes back up when you get an audio focus gain. So this is when you've returned from any of those transient losses. Now, one thing to note about the can duck is that it doesn't mean you have to lower the volume. If you're doing, say, a podcast player or something with spoken words where it's really important you get every word, or else, if you're talking for 10 seconds while there's another sound going on, that's not going to be very intelligible. So you can certainly pause or do whatever you need to do in that can duck scenario. You don't have to just lower the volume. So our updated life cycle, we're playing, we're pausing, we're stopping, we're ducking, well, lots of ings. But you can see we've kind of filled in a new row here where as soon as we start playing for that first time, we're going to want to request audio focus and then start our playback once we've received that granted playback. And then when we've actually stopped and we're done playing audio entirely, we'll want to abandon audio focus. And so that already makes us a lot better part of the overall system, right? We're no longer going to be talking over other apps. It's great, but it's not all we can do. Actually, one of my favorite broadcasts of all time is the becoming noisy, or the noisy broadcast. So this is actually when, say, you're listening on headphones and that type of thing, and then your speaker comes out, and all of a sudden you're blaring to the whole audience. And we can't really control what our tastes in music are for our users, but we can prevent them from some embarrassing situations on that case by registering just a simple broadcast receiver that listens for that becoming noisy intent and then pauses our music. So in this case, we're going to want to tie this to the life cycle of actually playing audio. Right? There's no reason to listen for being noisy if you are not being noisy, right? So we'll register when we actually start playback, right after we get audio focus, and then actually unregister as soon as we pause playback, right? So in this case, it's really more of that little bit of connection in there to say like, okay, well, I really don't want the user to get into this bad scenario. So added it, register, unregistered, easy, done. Okay. Now, at this point, we're actually fairly well off from an audio perspective, right? We're not going to be playing audio when we're not supposed to be playing audio, but there's a lot more we can do to be an amazing app. Another part of it is really that sense of controlling audio playback, right? That reaching for the next track button or the pause button, right? These are the kind of things that people are going to use your app and do a lot, right? And we don't want to make that really tricky to use. We actually want to make it as easy as possible for users to get and control your media playback. And thankfully, there's a lot of ways to do that in the Android framework. One of the first ones that you might think of are headphone and Bluetooth controls. Now, for me personally, this is probably the most frustrating one when apps don't do it correctly. If you're in your car and you have integrated Bluetooth controls, those are the kind of scenarios that users should not ever have to go into your app, to find a pause button or hit the play button or anything like that. Instead, you should be handling these in your app. Now, we generally call all these headphone and Bluetooth controls collectively media buttons. So, in fact, they're actually just like any other keyboard event from Android's point of view. You get a key down when someone depresses the button and a key up when they release the button. Now, by default, the system's actually going to send out a broadcast whenever it gets one of these messages using the aptly named media button intent. And this intent actually includes the key event of the down or up and what action was actually hit. So in that sense, we can create our own, but in the support library, in the brand new 23.1 release that came out just a few days ago now, we've actually created a media button receiver, which does exactly this for you. Now, one of the problems with this kind of broadcast receiver is because it's a broadcast receiver in your manifest, somehow you need to get that information into your actual service that we've been talking about, right? You can't necessarily play from the broadcast receiver when it's the service. How do you do all that communication? And that's what media button receiver actually does for you. So how do you set up a media button receiver? You just register it in your manifest, right? It's a simple receiver. You see our media button intent filter here. Note that you haven't written any code at all, but what it'll do is when it finds a service which also has the media button intent filter, it'll automatically pass any intents that are received, such as those media buttons, onto your service. And now the service can actually handle those play and pause and toggle play controls in its onStart command. No longer you have to write this communication layer between your broadcast receiver and your service to get through everything. There's one problem though. If you write this, it won't work at all. So why is that? We wrote media button receiver, right? It should just work. It turns out that sending a broadcast to every media app on your device, not a good idea. You don't want to see what happens when you hit play on 10 different media players all at the same time. It's not pretty. Thankfully, autofocus handles most of it, but it will look funny. So instead, the system has this concept of a preferred media button receiver. It's basically a last wins kind of a model. So the last one to register that they want to be the preferred media button wins. Very similar to kind of the autofocus model, where as you're the last one to say, I want autofocus, you get it. So if you've ever had play music respond to a Bluetooth control when you're in fact listening to another app, that's because something's messed up in the preferred media button receiver. So that is one of many things that Media Session Compat gives you. Now, Media Session Compat does a lot. It's actually based on a Lollipop edition called Media Session, funnily enough. And it's our entry point between our media app and all of the media framework APIs. So all of the things that we're going to talk about here shortly are all kind of tied into this one object. Now, the nice part is that this object, even though it was built in API 21, auto-translates to older APIs. So if you ever used remote control receiver and other things we won't mention, those deprecated APIs, you don't have to use them. Media Session Compat will automatically do the right thing for you. Now, first we'll want to create our media session. We'll create it in our service, pretty much as soon as our service is created, just like our media player that we'll create as soon as possible. Passing in a logging tag, so if anything goes wrong, it's very easy to actually debug where in the steps it actually fell apart. And then you'll want to set two flags. One that we actually want to handle our media buttons, and the second one is transport controls. These are play and pause type of controls from within your app. You basically just always want to set them. I'm not sure why they're not the defaults. And then the last thing is setting that callback. Now, the callbacks are actually really important. That's where you get on play, on pause, on stop. It's basically that central entry point between where all the media APIs are going to go and your actual media player, right? So the onPlay method of here would cause play on your media player, right? So we haven't actually set that we want to be the preferred media button. Thankfully, it's one method, set active. I bet you can guess what the Boolean does. True means we want to become the active media button receiver. False means we're done and you can leave. So it actually does a lot behind the backgrounds, but one of the things it does is the media button intent. Now, once we have this media session compat set up, we can actually take advantage of the other part of media button receiver, which is its handle intent method. The handle intent method, which you can put in your onStart command, automatically translates all of the key events, extracts them from the intent, does all that work, and just hands them off to your callbacks. So now you don't need to do that translation of, all right, well, this is a key down of toggle play, and then that translates to an onPlay command. You just pass it on through and keep using the callbacks that you've defined as part of media session compat. Now, how does media session know anything about what toggle play should do? We haven't actually told it if we're playing or not. That's what media state compat is for. So you can think of media state compat as kind of all of the information about what your app is currently doing, right? So while you may know within your app, are we playing, are we pausing, are we buffering, right? The system knows nothing, right? You haven't told it anything. So we'll have to do exactly that using setState. Now, setState is kind of the playing paused. It's actually what looks like an enum, but is in fact not an enum. It's just ints. And we'll also want to include our position, so how far along we are in the track, if that's applicable to you. And then we also have set actions. So set actions are things like, do I support play pause? Do I support stop? Do I support next track, right? Not every player supports going to the previous track. You'll really want to make sure that you actually put all of the things you support, because this is what's going to show up on various surfaces, such as the lock screen later. And it's also how media buttons get filtered out. If you say you don't support pause, and someone clicks the button on their headphone, you won't get an on-pause playback or callback. So really make sure that you're actually also setting the actions. Now, you'll note that both of these are combined into the same playback state compat. Turns out that in most media apps, these are kind of tied together, right? While you're buffering, you probably don't have a pause action. When you're buffering, you probably don't have a skip to next. But you may still want to support a stop command, right, to be able to stop things if it's really buffering on forever. So they are kind of combined together under the assumption that you'll probably change both of them at the same time. So probably one of my favorite features in Ice Cream Sandwich are lock screen controls. So kind of that play pause, pretty album art, probably the best feature besides the whole combining phones and tablets and all that. It's fine. Lock screen controls, definitely the best. Now they're actually fairly easy to add. The only thing we've been missing so far, because we already set our actions, is actually just some metadata, including a picture, right? We can't really show anything on the screen if we're not showing that type of thing. So, and that's where media metadata compat comes in. Again, we'll just kind of set it in. You can kind of think of it as a bundle of all of the information about what's currently playing. Now, note, this is actually used in more places than just the lock screen. So if you've ever noticed on Android Wear, you get a little notification of playing audio and stuff. It's actually using the metadata you pass in, that album art, all that information is coming from the media metadata you've set. So what kind of information goes in here? It's, a lot of the basics, right? Title, artist, album, all kind of really important ones. If you're using fixed duration tracks, you probably want to add the duration. It goes really well with that position we already set. On the image size, you can add bitmaps directly. please do not add any like 4,000 by 4,000 giant bitmaps. That's kind of the case where URIs come in, where you can actually pass a URI to just a larger image that then can be downloaded later. Ideally, these should be content URIs so that other apps can read from them. I have a storage talk tomorrow that talks all about how you can actually set up these URIs really easy. But these are just kind of some of the most important ones. There's actually like 27 of them in total. So read through the documentation. These are probably the ones I'd recommend off the top. So we've added our media session compat. Just a few more steps along the way. We did our created, setting the flags. Playing, we'll want to set active to true, set our metadata, set our state. Similarly, anytime we pause or buffer or change anything, really, we'll want to make sure our state stays in sync with our app. As well as then when we're actually stopped, we'll set active to false and say, hey, we're done. And then release when ROM destroyed to return all those resources. Now, talked about lock screen controls. They're really great, but we kind of removed them in 5.0. Turns out that notifications are the new hotness and are kind of what the lock screen is all about now as of Lollipop. Now, it turns out we probably should have been using notifications all along. The fact of having to lock your device just to use a play pause button, probably a little silly. So notifications kind of give you that access anywhere. Anywhere in any app, you can pull down the notification tray and play and pause and that type of thing. But building that custom notification can be a lot more complicated than you want, so we built it all for you. We have notification compat media style. So this style kind of automatically allows you to add media buttons without having to create giant custom notifications every time. So on less than API 14, in fact, you couldn't add any buttons to a notification. Like there was a time when all a notification was just a single tap target. I know, it's like years ago, right? But we still support it here. You'll get just a basic notification that allows someone to click into your app. Starting in API 14, you can actually have buttons. So we support buttons in that single line state. You can have up to 3 buttons right there in the notification. API 16, Android 4.1, added expanded controls. So here you'll get a larger image for album art, and you'll get up to 5 controls. And in Lollipop, we actually switch over to the framework media style. So basically, from there on out, you'll actually have the exact styling across every device, and it'll look just like any system one. Now, one thing to note is that all of this notification compat is in app compat, not necessarily in the support v4, which is where all the rest of the notification compat stuff is. So just keep aware of that. Now, I like writing boilerplate code once. I never want you to write boilerplate code. So I've come up with kind of a media style helper class, which kind of does a lot of the building, taking in a media session and then building out a notification compat for you. So we can actually extract a lot of information if we've set our media metadata. In fact, media metadata has a very nice method called getDescription, which kind of extracts the most important information, those information we pulled out, that we called out earlier, such as title and artist, and actually allows us to build our whole notification directly from that. Getting title, get our description, doing all this work for you so you don't have to do this boilerplate work. In fact, we can actually pull out a session activity. If you've set it via media session compat, set session activity to launch your activity automatically. Now, on 5.0 plus, you can actually hide notification contacts on the lock screen. But generally, we actually do want to show media controls on the lock screen, even in those cases. So we can set it as public. Now, you'll note here for the delete intent, which is when a notification is swiped away, we're actually using a separate helper called getActionIntent, which you'll pass in a key event, and then it'll automatically create the pending intent for you. Thankfully, that's another easy method that I've created, and both of these methods are on a gist on GitHub. which means you don't have to write it ever again. It's fantastic. So we can actually just stick with something very simple. In fact, when we create it from our notification, and then we'll want to set kind of the small icon, right, that appears on the top, and then set the color. Now, color works a little bit different from media style notifications. If you've ever seen a notification on 5.0 Plus, the small icon, right, the app icon, can be colorized in the background. You'll see a lot of Google apps do this. In media style notifications, it actually is the whole background of the entire notification. So if you're using bright orange, I'll want to stab your eyes out. Don't use bright orange or any color that you want to test it out and make sure that the color that you're setting makes sense with your actual color palette and doesn't look ridiculous, because it has a strong chance of looking ridiculous. Now, media styles wouldn't really be much of anything without actions. So here I'm adding a pause action using our get action intent. And then our style actually just uses two methods, one called this set show actions in compact view. So this is what sets what actions appear in that single line view. By default, none will. So you probably want to set some 0 index array of what buttons to have. So if you want the second button you've added, you'd add button 1. If you want the second and third, 1 and 2, etc. And then the last part, which is super critical, but if you forget it, people will hate you, is media session. So the set media session is actually what allows your notification to work on Android Wear. If you don't set this, then you'll get a beautiful notification on Android Wear, and then you hit the pause button and nothing happens. It's the worst feeling in the world. You're like, oh, wow, that looks amazing, and nothing happens. But what it's actually doing is it's using a session token, which is kind of the unique identifier for your session, and passing that on to apps like Android Wear such that they can control your audio and give you callbacks in your callback. So we've added our notification. We'll want to show it as soon as we start playing. Right? We'll want to update it anytime the state's changed. And then, of course, remove it when we've stopped and are all done. But I talked about notifications. Now, it turns out that there's this concept called Foreground Services, which kind of raise our background services priority to a higher level such that it won't get killed. Now, Foreground Services require a notification, which thankfully we just built. So we can actually take advantage of this for our media service. Now, it's actually really important because we really don't want our service, which is playing audio, to die in the middle of things just because someone launches Chrome and it takes up all the resources on your Android device. Believe me, they're working on it. But what we want is we want our service, because it is actively playing music, to live just a little bit longer and hopefully survive forever. There's one caveat, though. Once you've started a notification with Start Foreground, pre-Lollipop, it was ongoing forever. You could never swipe it away, which was actually super frustrating. So we fixed it. But it actually affects media notifications the most. Because if you think about it, you're going from a foreground, I'm playing audio, to being paused, not foreground, very often. And you don't want your notification being completely removed and re-put in because it looks really janky. So our media style actually gives us two methods which allow you to kind of work around that, setting a cancel intent. And basically, this just adds a little X in the corner of your media notification, which allows them, even if they are ongoing forever and you're annoying users to no end, they can just hit the X and close out your notification. In this case, we'll set the intent to just be a media stop, just like it got swiped away. So it always is the same, whether it's pre-Lollipop or post-Lollipop. Nicely enough, on Lollipop, these methods just don't do anything, because it doesn't apply on those levels. You'll be able to swipe it away as soon as you say, stop foreground, false. So stop foreground false means I don't want to be a foreground service anymore, but keep my notification up there, right? I'm still alive, right? But I don't necessarily have the requirement to be at the top of the priority list, right? If your music is paused forever, right, users probably won't notice if it actually gets destroyed or not. And if you're really under memory pressure, it is kind of important to be able to have Android clean up your service. So we've actually done a whole lot, right? We're playing, we're pausing, we're stopping, we're not stepping on other apps. Bluetooth controls work, lock screens, media controls and notifications, Android Wear, and we're reliable under memory pressure. That's pretty good. Now, I just forgot one little thing. You have an app that has a UI, that has controls, and we haven't talked at all about how that service interacts with your actual UI. Now, you could be doing something super simple and saying just start service with custom actions, but that doesn't get you the two-way communication you want, right? You want so that when the service switches to the next song, your UI stays in sync. And ideally, we'd want to actually reuse those callbacks we were using so that when someone hits play or pause in your UI, your callbacks you've already set up for media buttons are automatically handling those things. Sounds pretty amazing, right? So we built a class for that. Built a lot of classes. MediaController Compat kind of does all of that for you. Once you've connected to it, then you'll actually get access to all of the metadata you've set, so you can tell what the current playing track is. All of the state, so you can tell if you're playing or paused and what position you are, as well as transport controls. So these are the methods of like play, pause, skip to next, right? Kind of useful things to have. And these pipe directly into your callbacks, right? There's no extra layers you need to build, no callback craziness. It's just already built for you in part of transport controls. And because no one likes polling for media changes, you actually get a set of callbacks. So these callbacks are the things that say like, oh, the media metadata has changed. We've switched to the next track. Oh, we went to buffering. Right? Instead of having to poll your service or have your service send notifications every time, whenever you call set state or set metadata, which we're already doing, right? Then our callback will instantly get a callback saying like, hey, the metadata has changed. You should update the UI to match the new metadata. All of a sudden, our UI is now totally in sync with our service without us having to write any crazy communication code between our service and our UI, because we're using MediaController Compat. There is one wrinkle, though. That token that we need, that media session token that we pass to our notification, it's actually also what's needed for MediaController Compat. But the person who knows about our token is our service. We somehow need to get that to our UI. Now, it doesn't really matter how you get it to your UI, but we do have a second set of classes called Media Browser Service and Media Browser, which were introduced in API 21, which do all of this connecting and passing the session for you. Nicely enough, you don't actually need a token to connect to a media browser service. And you'll get access to actually new APIs as well, such as being able to browse media items entirely. This allows you to actually build your UI off of the information that's already in the service. For example, you could have a list of tracks, and that would match what's in your UI. And you wouldn't have to create a separate data store for that. You can use the Media Browser Service and Media Browser to connect to it. Note, this is also how all the Android Wear or Android Auto integration works. So Android Auto is actually connecting to your Media Browser Service and then building the whole UI, all of the controls, all of the information from the data you pass back to it. You'll also note that Android Wear adds a browse action. You'll never find it on your watch, but if you're playing audio, you scroll all the way to the right, you'll find browse. This allows them to actually check the next track or skip multiple tracks or change playlists and stuff directly from the watch. Actually pretty useful if you're one of those kind of people who hates pulling their giant Nexus 6s out of their pocket. Now moving to Media Browser Service has one thing you'll need to do, call set session token in onCreate, and obviously move over from an extending service to extending media browser service. Now, it also gives you those new methods on getRoot, which is kind of the verifying what the calling app is. So if you want Android Auto to display different data, you can pass it a different route from, say, your own app, right? So if you have different layouts for each one. And then similar to a file browser, for example, onLoadChildren gives you a list of all of the items. Some of them may be browsable items, right? Different folders and subfolders. Other ones might be playable ones. Similarly, onLoadItem just gives you details about a single item. So you can see how like you may be able to build a UI out of these methods, right? You may be able to say onLoadChildren and get a list of all of the songs and all of the albums or all of the most recently played tracks. It doesn't really matter what it is, but that same list of tracks can be really done with onLoadChildren, and then onLoadItem can actually give you the details about an individual item. Now, if you want to learn more about this, we actually have a giant sample app which does everything in the world based on media browser service called Universal Android Media Player, UAMP. Like I said, currently media browser service is API 21+, and so is Universal Android Music Player, UAMP. But I would like to say that we are working on backporting both. So we're working on getting media browser service to lower API levels, as well as moving over UAMP over to support a wide variety of devices. So you can actually use all these things much more, even if you're not quite ready for MinSDK 21. Anyone? Huh? Oh, yeah. All right, great. Perfect. Min API. You can use it right now. It's great. You don't have to switch to any of this. Now, if you're not MinSDK 21, then you should be. But you know, they're really the best users. But I understand. Maybe that doesn't make sense for your app. There are a few other ways other than using MediaController to get the session to your activity. You could do it super simply. Use, say, the event bus app of your choice, RxJava, whatever, or use a static method in your service and a local broadcast to say, oh, it's changed. Super easy to build, but maybe not supporting kind of the multi-process structure. Actually, multi-process is a lot more important for a media app because you really want that background service to be as low memory, as low impact as possible, and have your UI not impact the actual service. So if your UI crashes because something's gone horribly wrong, you don't necessarily want that to kill your whole background playback also. Another option is to kind of fake what media browser service is actually doing under the covers and bind to your service, build an API that just returns a token for you. No one really wants to build this, but we actually have really good training on bound services on developer.android.com if you're interested in learning kind of some of those approaches to do that. The simple matter is it doesn't matter how you get a token to your UI. It just matters that it gets there. So whatever approach you want to use now, and then if you want to use media browser service later, it's totally possible and it works great. So everything that we've done today can be summed up in one slide. Probably should have shown this at the beginning, but then you might have left. But this is the canonical slide of all of the things you may want to do. I did note once that the stopped state, right? If you do want to keep your service around for a little bit longer, right, you don't necessarily need to remove everything as soon as they hit the stop button. You may keep it around a little bit longer. That's fine. But we've learned about kind of audio focus and the noisy broadcast, the becoming noisy, to really play nicely with other audio playing apps. Media buttons, lock screens, and system information with Media Session Compat. Then media style notifications, Android Wear support via media style, and then media browser service for Android Auto and building your UI based on your information. So feel free to reach out to me on Google Plus or Twitter if you have any questions. Otherwise, I'll be right down here for any questions in the room. Thanks so much.